Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in the MBSS 222. And this is going to be a podcast on the distributive property, which is one of the most important properties that we have in algebra. And is probably one of the most misused or mistake the one that with the most mistakes prone properties that we see in algebra. And as teachers, we really think it's the most simple, and we explain it, and then students have the most difficulty with it. And because it's so important, I first want to give you a couple of word problems. And you're saying, oh, why start with the word problems? That should be the most difficult. But I want to start with the word problems with the distributive property to show you where the distributive property originates, why the distributive property is so intuitive to our life that we really use it almost every day without thinking about it. And we do things in our everyday life that are distributive property, and then how we can apply that to the algebra situations that aren't intuitive, that involve those nasty little things called variables. So we're going to start out, and you can read this problem, and probably already have while I was doing my talking here, and ignoring everything I said. But in this case, we're going to say Ted works at Goodsell, and next week he has 5 trucks coming in, and they have shipments from Apple. And each shipment will contain 12 iPads and 40 iPods. And next, he needs a storage unit to store each of those packages for display or whatever. We're just, that one we're going to kind of go with. But he needs a storage unit. And so he needs to know how many storage units he needs. He's got 5 trucks and 12 iPads and 40 iPods. So how many storage units will he need? Well, let's write down what we have. We have the 5 trucks. And on each of the 5 trucks, he'll have 12 iPads plus 40 iPods. Well, since we're not really treating the iPads or the iPods differently in this situation because they each can need 1 storage unit, we can just add the iPods and the iPads together for 52 storage units. Because each one gets 1 storage unit, 40 plus 12. And then for the 5 trucks, 5 times 52, and I took my calculator and multiplied this out. I'm not doing it in my head, but 5 times 2 is 10, carry my 1, 25 plus 1 is 26, and I get 260. And that is one way that we do this multiplication. The number of items coming in, each item needs 1 storage unit, 52 times the 5 trucks is 260. Now that is using order of operations. I added the items and then multiplied out. There is another way that I could do this using the distributive property. And that would be to say that the iPads need 60 storage units. Because each iPad is 12. 12 times 5. 5 trucks of iPads. 12 times 5 is 60. 5 times 12 is 60. And then for the iPods, I have 5 trucks of 40 iPods. pods. Here's my iPads. Put a little plus sign and slide that in there. And 5 times 40 would be 260. So I would be getting in 60 iPads. Excuse me, that's 200 plus 200 iPods. And since each one contains one storage unit, that would be 260 storage units. And that's how we use distributive property, because I distributed that 5 trucks to both the iPads and the 5 trucks to the iPods, and distributed it to the 2 different items. I multiplied 5 times the 12 and then 5 times the 40. And that's the distributive property, where we distribute the multiplication over an addition or a subtraction is a distributive property. Now I want to do one other word problem, and then we'll just go on to some applications like you'll see in section 1.7 of the text. And it's possible that that section number may change if we change books, and I won't change the podcast. But in this case, Ted's working on commission at Good Sale, and he earns $320 salary plus his commission. But since his commission varies depending on what he sells, we'll let that be X dollars. And we want to write an expression using the distributive property for his salary for the next month. And we'll assume that 4 weeks in a month. We won't do that little extra, but just 4 weeks in a month. And then we want to simplify that expression. Well, he gets $320 plus X dollars in commission each week. And he has 4 of those weeks. So we need to multiply that by 4. So that's the expression. Now, how do we simplify that? Well, we cannot add the 320 plus X, because in this case, we do not know what that X dollars is. In the previous example, we could add the number of 12 plus 40 because we know that each of those require 1 storage unit, so they were really like terms in terms of storage units. And even though these are both dollars, this dollar amount is unknown. It can vary. That's why we used a variable for it. His commission can be different each week. However, the 320 is set. And we know that every week he'll earn $320. And as he earns $320 each week, 4 times 320 tells me that his set salary for the month is $1,280. 4 times 320 gives me that $1,280. And his commission, and let's say he earns the same commission every week, and that's what we're assuming in this problem, would be then plus 4 times X. And again, this one does have some limitations because we assumed he earned the same commission every week. And that probably wouldn't be the same amount every week because it would probably vary week to week. But we're assuming he makes the same amount of commission every week for the month. So in this case, $1,280 plus 4x would be an expression for his salary for the month. Now, if Ted averages $200 in commission each week, in other words, that's his commission for every week, what would his total salary be? Well, in this case, that would mean that we're going to plug in for that X $200. In other words, we're going to let X be his average commission for the month, which per week, and we'll put it in place of the X. Then we'll get 1,280 plus 4 times 200, which would be 800. Add those two together. And again, I'm using a pre-done calculations here, but you take your calculator out or take time to write those out, and if we add those together, we get 2,080. And the key here is that we're going to plug in place of the X what it told us it would be, which is $200 in commission. In place of this X, we'll put 200, and then 4 times 200, doing the multiplication first, and then the addition, and then we get 2,080, which would be his salary for the month. So this is an application of the distributive property. Now let's get down to some actual problems with the distributive property and using those in very simple, straightforward applications. And remember I said that the distributive property is over either addition or subtraction. Notice some things about this. We have a number that can be either in front or it could be in the rear of an expression. Inside the expression is a set of terms that are either added or subtracted. And remember, a term is something that's separated by a plus or a minus. It is two parts. They're not multiplied, they are added or subtracted. And then we're going to simply take this 5 and multiply it with the X, and then multiply it with the 3. And I'm using the arrows to help emphasize this, and until you get the hang of it, you may want to do so as well, but they're not necessary if you get the hang of it really quick. In this case, that gives us 5 times X, which is 5X, and then 5 times 3, which is a positive 15. And as I do these, I always tend to do it in this order. I think about my sign, my number, and then my variable. SNV, sign, number, variable. I decide what my sign is going to be, then what my number is, and then if I need a variable to go with it. So when I look at 3 times Y, they're both positive. A positive times a positive is a positive, so I know I don't need to write a sign down. Then 3 times 1 is 3, and I need to bring my Y. Sign, number, variable. Then 3 times a negative. A positive times a negative, the signs are different, so I need a subtract sign. Then I have 3 times 2 is 6, and there's no variable. And you may not have gotten to your sign numbers yet, so if not, then it's obvious that it's going to be a subtract and we're not going to be changing any of our signs. 4 times 2 is 8. Then bring the X, bring down the subtract. 4 times 5 is 20. Notice on all of these, we multiply the first, then we multiply the second, and there are no like terms because 8x and 20 are not like terms. One of them has a variable, the other one does not. There are no like terms. And we can only add together those things that are like terms. In my previous problem, I didn't add iPads and iPods. I added together the storage units needed for both. Okay, now let's look at this one right here. 7 times n is 7n. Bring down the subtract. 7 times 4 is 28. Bring down the plus 3. Notice the 3 did not get multiplied. This end parentheses is a stop sign. It says no longer are you multiplying. The distributive property distributes over a set of parentheses. And when you get to that end parentheses, you end the distributive property. That plus 3 is just out there by itself and comes down. Now we need to look at what we have left. And we have like terms. We have a subtract 23 and a plus 3. In this case, we do want to look and follow our rules of operation. And if you're down 28 and add 3, that's going to leave you a negative 25, and then bring down 7n. Now, it could be, and I'm probably going to leave this podcast up, and I may end up having to redo this podcast, so it may be up temporarily and then redone. But you may not, in section 1.7, have gotten to your signed numbers yet, in which case none of your homework will have problems that require you to do signed numbers at the end, but there will be some that will require you to add like terms. So don't concern yourself about the signed numbers, but do add your like terms. For those of you watching this that do know how to do your signed numbers, just remember that that's a negative 28 and a positive 3. So you're going to add, since the signs are the same, you're going to subtract and keep the sign of the larger number, which makes that a subtract 25. And in case if I redo this, it won't matter. And sometimes I end up making a long story that doesn't even need to be told. But look at that, and as you do these, and be careful, and remember to use your distributive property carefully and learn it well, because it is a property that we use in every math class that we have here at Walter State. And thank you for watching. If you have some additional questions, be sure to stop by the math lab in the fall and spring semesters in MBSS room 222. Thank you.